Alright, so let's look at our angles. So let's fill in our notes. If you'll notice right here, we have an angle, theta, and we have one side on the positive x-axis and the other side is over here in the second quadrant. Okay, and the angle is actually being measured in a counterclockwise direction. So that's going to be very important in just a moment. So an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So we can see that this is in standard form because the vertex is at the origin and one side of the angle is on the positive x-axis. The ray on the x-axis is always called the initial side. So this is the initial side. The other ray is called the terminal side, which is this one right here. Okay, now counterclockwise rotations result in positive angle measures, and clockwise rotations result in negative angle measures. One revolution is going to give us 360 degrees. Okay, so if we look at number 1, we have a 75-degree angle and we want to sketch the angle in standard position. So if we have an angle in standard position, the vertex is going to be at the origin, and then you're going to have one side on the positive x-axis. That's your initial side. Now think about what you've got here. You've got 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. That's your complete revolution. If you have a 75-degree angle, you're going to be in the first quadrant right here, between 0 and 90 degrees. Halfway between 0 and 90 is 45. So my 70-degree angle, or 75-degree angle, should be approximately here. Now, since it is a positive angle measure, you're going to start at the positive x-axis and you're going to arrow up to the terminal side. And this is your 75-degree angle. Now, when you have a negative angle, you're going to move in the clockwise direction instead of counterclockwise. So once again, you're going to start at the origin and you're going to have the initial side at the positive x-axis. So if this is 0 and we go clockwise instead of counterclockwise, this will be negative 90, this will be negative 180, this will be negative 270, and this will be negative 360. And of course 0, and add that. Okay, so if we have negative 160, that's going to be between negative 90 and negative 180. It's going to be very close to the negative 180. Now this one is going to go in a clockwise direction. So this will be negative 160 degrees. Okay, excuse me, I looked at that. Okay, now 430 degrees, if you'll notice, that's going to be greater than 1 revolution. So in order to figure out what angle I need to put on the coordinate plane here, I'm going to take 430 and I'm going to subtract 1 revolution away. And that's going to give me 70 degrees. So I'm going to draw a 70-degree angle. So once again, I've got 0, 90, 180, 270, and 360. So a 70-degree angle will be a little less than that very first one that we drew. Okay, and then here is my initial side. But when I draw it, I need to indicate that I've already done 1 complete revolution because I have that 360. Then I'll pass 1 revolution and go on up to your terminal side. So this will be my 430-degree angle. Now, another thing that we have to talk about when we're dealing with circles is using radians as opposed to degrees. A radian is a unit of angle measure based on the arc length of the circle. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So look right here. Here's the radius, okay, and here's another radius, and here's our angle. This is the intercepted arc. Okay, so when you find the arc length of this part of the circle and it equals your radius, what you're dealing with is 1 radian. Since the circumference of a circle is 2 pi r, we can get our 360 degrees and we'll know that it's equivalent to 2 pi radians. Okay, and 180 degrees, which is half of the circle, is going to equal pi radians. So that tells us we deal with pi when we're dealing with radians. So in order to convert between degrees and radians to degrees, if you want radians, you take your degree and you multiply it by pi over 180. If you want degrees, you take your radians and multiply it by 180 over pi, and you can convert the two. So looking at 4, 5, and 6, we have degree measures, and we want to convert those into radians. So we'll take 30 degrees and we'll multiply it by pi over 180. So 30 into 30, 30 into 180 will give us 1 times pi, which is pi, over 6, and these are radians. 150 degrees is 150 degrees times pi over 180. Cross cancel, and you'll get 5 times pi over 6, and these are your radians. And you can have negative radians just like you can have negative degrees. So negative 220 times pi over 180. Okay, so all of these I've converted from degrees into their resulting radians. When you think about 30 degrees and you have your coordinate plane, remember this is your initial side and your terminal side will be right here with 30 degrees. So from the initial side to the terminal side counterclockwise, you have 30 degrees. Well, it also has a radian measure of pi over 6. Both of these values, while clearly different, indicate the same angle here. Just like when you have 150 initial. Oops, I might have made that a little bit too close to the x-axis. So 150 degrees and 5 pi over 6, that's the same angle. Okay, so let's look at going in the other direction. You have your radian and you want its resulting degree. So if you have 4 pi over 3, you're going to have to multiply it by the reciprocal of what we did before, 180 over pi. And the reason we do this is so that our pi's will cancel out. And 4 times 60 is 240 degrees. Because this is a degree, make sure you put your degree symbol. Negative 5 pi over 36, we'll multiply this by 180 over pi. And so your pi's will cancel out. Let's see, 36 times 5 is 180. So that'll give me negative 25 degrees. And then 7 pi over 4, let's multiply this, times 180 over pi. My pi's will cross cancel. And then we'll multiply 7 times 45. We'll get 315 degrees. Now, when you decide to use your calculator, if you don't work these out by hand, for example, when you do 30 times pi over 180, you'll have to do 30 times. Do not put pi in that numerator. Put 1 instead and put it over 180, and you'll get your 1/6. Just multiply 1 times pi, and that's where the pi over 6 comes from. When you have 150, make sure you multiply it by pi over 180, but instead 1 over 180, because if you put pi in your calculator, it's going to work out pi. And you see that you get 5/6, so just put 5 pi over 6. So on the next one, negative 220, you're going to multiply it times, instead of pi over 180, put 1 over 180. That'll give you negative 11 ninths, which is negative 11 pi over 9. Okay, when you convert here, since your pi's cancel out, you can do 4/3. On this one, since your pi's cancel out, okay, so say you're getting all of your numbers without having to put pi in your calculator. Okay, so all of it works out beautifully.